combined vertical accelerations according to DNV. So the transverse acceleration AT is equal to the square root of AY squared added by gravity times the sine of the roll angle added by ARY squared. Okay, so have a look at the items here. So we have the AY first. Well, we know from the DNV model that AY, that's acceleration in Y direction. Maybe it's good to make a sketch. So we have the vessel over here, and for the axis, this alongship is the x-axis, and to the port we have the y-axis. Okay, AY is defined as 0.3 times gravity times A0. Well, this factor A0 can be calculated by A0 equals 3 times the wave coefficient divided by the length of the vessel added by two other coefficients, CV times CV1. Okay, well, let's have a look at this one. The CW, you can take that from a graph, but in the formula it's 10.75 minus 300 minus the length of the vessel. Well, in our case, the length of the vessel is 130 meters. Minus 130 divided by 100 to the power of 1/2, 3, 2, which equals 8.53. Now we have two other constants, CV, which is the square root of the length of the vessel divided by 50, which would be something like 130 divided by 50, and this is 0.23. This happens to be greater than 0.2, then the manual says take 0.2. Second coefficient, CV1, equals the speed of the vessel divided by the square root of the length. Say we have a speed of 15 knots. That would make 15 divided by the square root of 130, which is 1.32, which happens to be greater than 0.8. That's fine, so we have 1.32. From this we can calculate the A0, so we go with these numbers, we go back there. So we have, we fill it all in, you can do that yourself, and this will give you something like 0.46. Well, the A0 is input for the acceleration in y direction, and so we have 0.3 times 9.81 times the A0 we just calculated, 0.46, and then we get a AY of 1.36 meters second squared. Okay, that's the first step. Now we have to calculate here this part. So we would like to know what is the maximum roll angle. Well, let's try that one. The maximum roll angle. Maximum roll angle is defined as 50 times C divided by beam of the vessel added by 75. Well, this C, which is in the numerator, is 1.25 minus 0.025 times the roll period multiplied by a factor K, which in our case is K is 1.0 because the vessel has bilge keels. The idea is that if you have no bilk gauge, this will be a smaller number, and if you have something additional to bilk skills, the k gets bigger than 1. In our case it's 1, so here we have to calculate the roll period. Well, we do that with the formula 2 times kr, that is the radius of gyration for roll, divided by your gm. Well, the gm in our case is 1.8, and we have a beam of the vessel of 24 meters. So the kr, I have to move the screen a little bit. That's not the idea. Try again. Move the screen a little bit. So here we say that the kr, the radius of gyration for roll, is something like 0.39 times the beam of the vessel, is 0.39 times 24 equals 9.36 meters. Radius of gyration, and the gm, we know gm is 1.8. Well, we fill in this here. That means 2 times 9.36 divided by the square root of 1.8, and we get a roll period of 13.95 seconds. That looks nice. So we were busy with the maximum roll angle, so we can fill in these numbers. First I would like to know what is the C. Well, the C here, when you fill in the natural roll period, will give you something like 0.90125. Put it over here, you can do that yourself, and you get a maximum roll angle of 0.4552 radians, or if you multiply them by 180, so is 0.455 times 180 divided by pi, gives you a 26.1 degrees roll angle. That's quite a roll angle. Well, if we have these numbers, let's go back to where we started. We go up here, and then we say we just found out that this roll angle is 26.1 degrees. Next step is this IR acceleration in y direction due to roll. Back down. Okay, so the acceleration due to roll in y direction is something like your maximum roll angle. Beware, this is in radians, not in degrees. I always calculate back to degrees to get a better understanding of the angle. Times 2 pi divided by the roll period. This needs to be squared, and you have to multiply by RR. Okay, we know something, so this is 0.455 times 2 pi divided by 13.95 times DRR. So have a look at this. The RR is the vertical center of gravity minus the z-axis, the height of the z-axis. So the z-axis can be calculated by two formulas. It's d Mulder draft divided by 4 added by the Mulder depth, and this is the draft divided by 2. So if we say that the Mulder draft would be something like 30 meters and the draft itself would be 7 meters, and we have a vertical center of gravity of the cargo 90 meters. So we can fill this in. This gives us 13 divided by 4 added by 7 divided by 2. gives us 7.75 meters. So there's another way to do it, and you should do this because it says it's d divided by 2, which is in our case is 13 divided by 2, which is 6.5. And then the manual said the set is the smaller one of these two values, so this is a 6.5. So here we have the vertical center of gravity, which is a 19 meters minus 6.5. And then we have a R of 12.50 meters. We can put that in over there, so we have a 12.5, and this gets a 1.15 meters second squared. So now we have pretty well all the accelerations calculated, and now we have to calculate the total combined vertical acceleration. So this was a 1.15 meter second squared. So if you fill this all in, we get something like, at least I got that, 5.63 meter second squared, and it's quite an acceleration. Okay, so follow these steps to calculate your combined vertical acceleration according to DNV. There are other ways to do it, but this is the DNV way. Thanks for watching.